Good morning. Greetings from the Freeze camper. It's a brisk 36 degrees this morning, so it's a little chilly out here, but we are ready to learn about graphing cubics. So this is a new style of function for you, and let's just dive in and start talking about the parent function. If we are talking about cubics, what exponent do you think is going to be involved? Yes, cubes. That's to the third power. So the parent function for this is y equals x cubed. Remember, parent function means the most basic type of that category. So when we're graphing cubics, you'll see some kind of something getting cubed, x cubed. And there might be other stuff happening to it, and we'll talk about that as we go. But first, let's look at y equals x cubed. If you have a new function, the basic strategy is let's just find some points. So let's plug a 0 in for x. Well, what is 0 cubed? That's 0. What about a 1? Let's take a 1 and cube it. 1 times 1 times 1, that's still 1, not 3. Let's take a 2 and cube it. So 2 times 2 is 4, times another 2, that makes 8. Let's do 3 cubed, even though we won't have room on our graph. 3 times 3 is 9, times another 3, yeah, that's 27. Okay, let's also talk about some negatives while we're at it. If we take a negative 1 and cube it, that means you have a negative 1 times a negative 1 times a negative 1. So there are 3 negatives involved. 2 negatives will make a positive, but then there's another negative, so that comes out to be a negative 1. If we plug in a negative 2 times negative 2 times negative 2, 2 negatives turn positive, but then there's still that extra negative, so that would be negative 8. And if we do a negative 3, we would get a negative 27. So that's plenty to graph. So you might want to take a little piece of your graph paper and tape it in your notes here, or draw a graph real carefully and label it. So I'm going to split my screen for a minute so that I can graph it as well with you. So let's see. There it is. Oh, let's see. Which one should we use today? Let's go with this. I don't think I can draw on the small one with my finger. Let's go with this one. Okay, so let's see here. You won't be able to see that very well, will you? Let's see. I pull this down a bit. I think you'll be able to see that. So, 0, 0 is right here. Oh, come on. Right here. 1, 1 is right here. 2, 8, 1, 2, 1, 2, 3, 4, 5. I'm off the screen already. So let's see. 1, negative 1, and 2, 8 is off the screen. Okay, so it's going to make an S shape like this. Okay, it's going to start going very steeply downhill on one side and very steeply uphill on the other. So I think I'm going to pull up Desmos so you can see a prettier version of that, because my hand copy is not beautiful right now. So let's see. If I show you y equals x cubed, y equals x to the third power. So here it is. Here's a nice view of what a cubic looks like. So it has this S shape to it. That's different than what we saw with quadratics. Quadratics always had the U shape, either facing up or facing down. This has an S shape, and the arms are going in different directions. So that'll be something we'll look at today and in the coming days. So, oops. Okay, let me go back over here to Smart Notebook. So since this is a new parent function, we should talk about some of the characteristics, those big ideas that we visit whenever we have a function to deal with. So one of those questions is domain. So what would the domain of this be? Oh, my writing is bad when I have it split screen. Let me go back. Ha, it's always bad. But we'll go back to this view. So the domain. So domain has to do with the x's, remember. So how far to the left and how far to the right would this graph go? Another way to ask this is, what could I all plug in for x? Like if I wanted to put I put a 3 in already. If I wanted to put a 4 in for x, could I do that? Could I take 4 cubed? What if I wanted to put a 10 in for x? Could I do that? Could I take 10 cubed? What if I wanted to take put 100 in for x? Could I do that? So could I take 100 cubed? And the answer is yes, yes, yes to all of those. What if I wanted to go in the negative direction? So I wanted to put in a -5 for x. Could I do that? Could I take -5 and cube it? Yes, I could. What if I wanted to put in -200 for x? Could I take -200 and cube it? Yes, I could. So this is going to go, as far as left and right, it's going to go to -infinity to positive infinity. So I'm going to write that in interval notation here. Remember, when we do interval notation, we say how far to the left and how far to the right it goes. And we have the parentheses because you never actually get to -infinity or positive infinity. We keep going. So now what about the range on this? That's how high and low this thing is going to go, because range has to do with our outputs, our y's. Well, it's going to keep going up and it's going to keep going down. So this has a range of -infinity to positive infinity. That's different from what we saw in cubics, because remember, I said the wrong word, quadratics, the U-shaped ones, the parabolas, because they had a minimum value or a maximum value. They didn't go forever in both directions, but cubics do. So that's a difference in those two. Let's see. End behavior. We should talk about end behavior on this. So the end behavior of this one. So let me pull the graph back up for a second here. So if I look at this graph, so end behavior, you look at the two ends as you go to the left and as you go to the right. So let's look to the left first. So as I go to the left, what's happening to my graph? It's going really far down. Okay, so remember how we say this mathematically? So for the left end, we say as x approaches -infinity, that makes you head to the left. X's go left and right, so negatives go to the left. What do the y's do? They go down. Okay, so the way you say y goes down is you say y approaches, down would be -infinity. So there's the left end behavior. Now let's look at the right side. So to say we're going to the right, we say as x is approaching positive infinity. You can put the plus sign if you like. As x approaches positive infinity, that makes you go to the right. What's happening to our graph? So what's happening as we go to the right? It's shooting up. So the way we say up mathematically is we say that y approaches positive infinity. So there's the end behavior on that. Let's see. Oh, I want to point out something else about this graph. So this center point right here at 0, 0, at the origin, that's called the inflection point. It's like the center of the S. That's going to be really important because we're going to start using our transformations on this function next. So you want to be able to find the center of your S for the cubic functions. That's the inflection point. And then the other thing that I want to point out, just a minute here. Oh, it's scaled weird. That's what's wrong. Let me squeeze this so our boxes are each counting by ones. There we go. The other thing that I want to point out here, besides the inflection point, is the points 1, 1 and -1, -1. Okay, so those are going to be some critical points. I'll mark them in our table, I think. So let's scroll back up here. This one is a real nice one to look at, 1, 1 and -1, -1. So those make you go, up 1 and over 1 and down 1 and over 1 from that inflection point. So that's what the parent function does. Now we're going to see that stretch and compress in a minute, but those are going to be our reference points. So the basic cubic from that inflection point goes up and over, down and over. That's how you get that S shape beginning. So, all right, well, let's look at one of these with transformations. So, how about, let's see if we can get an idea of what the graph would look like. Let me put a graph on here. Let's go medium, I think, this time. Okay. So let's see if we can get an idea of what the graph would look like if we graphed y equals, how about 2 times x minus 4 cubed plus 2. Okay, so I don't want a 2 there, I want a 3. So it's a little different than the other number. Okay, so this should make you have thoughts of A and H and K because it's in that format that we've been talking about a lot this year. So I'm going to write that down underneath here. Y equals A times parentheses x minus H cubed plus K. So if you remember, when we've talked about H, that's the number that shifts things left and right. It's attached to the x in the parentheses, and x is the axis that goes left and right. Notice the formatting, it's x minus h. So what would our h value be in this case? Yeah, it would be the 4. Okay, so we're going to shift this s, this cubic, 4 steps to the right. It would be a positive 4 because the minus is part of the setup of the transformation here. So we're going to go 4 to the right. The k, what does the k do? Yeah, the k shifts up and down, and so it's a plus 3, so we're going to go up 3. So that inflection point of the s is going to go 1, 2, 3, 4 to the right, and then 1, 2, 3 up. It's really hard to draw with my finger. Okay, so that dot is where the inflection point of the S is going to be. Okay, so now I would like to get the next 2 points on the graph. Okay, it's on the parent function, it goes up 1 and over 1, down 1 and over 1. But we have an A value here. Do you remember what the A value does? Yes, it's going to stretch or compress it. This A value is larger than 1, so it's going to make it twice as tall. So instead of just going up 1 and over 1, like the parent function did, this one's going to be twice as tall. So it's going to go up 2 before it goes over 1. And down 2 before it goes over 1. So that's going to be the center of my S. Ooh, it's not pretty. Oh, it's really hard to draw in here with my hand. Let me see if I can do better than that. It's not a lot better. Maybe we should graph this on decimals so you can see what that would look like. So I believe that one was y equals 2 times the quantity x minus 4 to the third power, what was it, plus 3, I think? Plus 3. Okay, so here's a prettier picture of what that would look like. Notice the inflection point, that center of the S, is what moved according to the H and the K. We shift it left and right for H, up and down for K, and then we stretched it. So I'll show you what it would have looked like without the 2. Without the 2, it wouldn't have been as steep. With the 2 in there, it's stretched out. Okay, so it makes it more tall. Okay, now what I want to look at is if I give you the picture, I wonder if you can figure out the equation for this. What is happening in this? So I have the purple function on here. That's y equals x cubed. That's our parent function, what we're starting with. And I wonder how we can make that change into this green function that we have here. So the first thing I want to look at is how much is it shifted left or right, and up and down, because those will establish our H and K values. So if I look, so my purple one is centered at the origin. So the parent function always starts at 0, 0. But my green one, the inflection point is down here. I don't know if I can click right on it. Ugh. It would be at, it's supposed to be at -3. Okay, it's at -3, -4. Okay, so that means I must have shifted 3 units to the left and 4 units down. So let's see if we can write this here. I'm going to move this over here so we can see it. And then get a new screen. Oh, is that going to keep vanishing? Just a minute here. Minimize that. Here, I think this will work. Okay. I'll leave that there so it doesn't get blocked by my picture. So let's see. So y equals, I'm going to put the structure first, x minus h cubed plus k. I know it's going to be something cubed because I see that S shape emerging, so it's a cubic. So let's see. If we have shifted 3 to the left, that means our h number must be a -3. So x minus -3 cubed. And then as far as k goes, we've shifted 4 down. So that's going to be a -4 here. I'm leaving a blank for a for a second. We'll deal with that in a minute. Now, I see that double negative inside the parentheses, so I'm going to go ahead and clean that up and say x plus 3 inside of there. That's more typical. And then that plus -4 on the end, you can just write that as -4. We don't need to say plus a -4. It's fine if you leave it, but there we go. Okay, so now we want to figure out what the a value is here. So we want to look at those critical points from the purple function. So the parent one, from 0, 0, we go up 1 and over 1 to get here. And then from the inflection point, down 1 and over 1 to get here. So I'm going to go to the green one, and I'm going to look from the inflection point. How much do I have to go up in order to go over 1? Well, it's hard to click on it exact, but up 2 and over 1 will hit nicely. And here, down 2 and over 1 hits nicely on the crossbars. So that means my a value is 2. Oops, I need a pen to write with here. 2, because it's twice as tall. Does it look like a stretched out version to you of the purple one? I hope it does. So there's that one. Okay, here's another graph. Let's look at this. So I kept that parent function on there. That's the purple one. That's y equals x cubed. So if you look at the blue one, find that center of the S. It's right here at 0, -5. So I want to talk about the left-right and the up-down shifting that has happened from the inflection point on the parent function, which was at 0, 0. So it looks like we haven't shifted any left or right. That means our h number here is going to be a 0. But as far as k goes, we have shifted down. So our k number needs to be a -5. So we're going to have, now x minus 0 in that parentheses, I don't need to write the -0, so I can just put an x cubed. If you want to put the parentheses, you can. You don't really have to. The k value is a -5. Okay, now we have to figure out the a on this one. And if you look at these, can you tell that the purple one is like flatter, kind of? I hope you can see that it's a little flatter than the purple one. So let's look at the critical values here. So on purple, the parent function, if you remember, we looked at it goes up 1 and over 1, and then down 1 and over 1 to get to some points. So we want to see how much we have to go up or down in order to still go over 1 on this blue one. Okay, so from this point, from the 0, -5 here, if I want to go over 1, I'm only going to be a little bit up. Okay, so this point here, if I can get it to click directly on the 1. Looks like I can't. It's only like a third of the way up. It's not as tall as it was. This A value is going to be a 1/3. So I think on the ones that you will have on your homework, it will be clear how much it goes up and over. So I'm having a hard time clicking right here. I think they'll label some points for you. There you go. Okay, so when my x value is 1, so I've shifted 1 over from my inflection point. I've moved 1 over. Do you see that y value of negative? That would be 4 2/3. Before I was at negative 5. Now I'm at 4 2/3, which means I've only gone up a third. Same thing over here on the left side. If I go, there it is. If I go over 1 from the inflection point, I'm now at negative 5 1/3. 0.3 repeating is a third, so I've gone a third down. So the parent one goes up 1 and over, down 1 and over. This is only a third as tall as that, so that's why my A value is a 1/3. So, okay, one more. Okay, so I have one more to show you, and this one looks weird. What do you notice about that red one versus our parent function that's in purple? Yeah, it's going the other way. So if you look at it, it's been flipped. It's instead of going up on the right and down on the left, it's upside down version of that. Okay, so what was it that we had that made our parabolas go from facing up to facing down? Do you remember? A negative A value. All right, so looking at this, I know that this is going to have a negative A value. So I'm going to write y equals, I'm going to put my negative out there. Okay. So let's see how this has shifted. Okay, so oops, let me stretch it a little bit so our grid is counting by ones. I think that'll help. So my inflection point on the red line, or the red cubic function, is right here. That's where it's turning. So that should be at, it should be at 2,5 is where it should be at. So x is, it's shifting it 2 to the right. So that means I need an x minus 2. And the k value is up 5, so plus 5. Now let's look at the 2 critical points from the inflection point on the purple. Remember the up 1 and over 1, down 1 and over 1. Let's see what happens from this center on the red graph, this inflection point right here. There it is, 2, 5. Can't make it stay. If I want to go up 1 and over 1, okay, that hits right on the red curve again. And if I want to go down 1 and over 1, okay, that also hits right on the red curve. So my A value is just a 1. It's negative 1 because it's upside down, but it is still going up 1 and over 1. So if I look at my list, that's a match to what I have here in the red equation. So I'll show you if I take the negative off. Do you see how it reversed that cubic? But if I put the negative on, it flips it upside down like this. So that's what a negative A value will do. So let's see. Yes, I think that is everything that I need to show you for notes today. So you're going to do an assignment that's from the textbook. I'll post the PDF of it. So remember that Jesus loves you and so do I. So do your math.